Hello everyone, in this video we are going to see linked list introduction. You might heard of this name during college and other programming scenarios. This is a very important topic in the interview perspective and for the computer implementations also. In this video we'll see what is the linked list and some of its types involved in the computer data structures, and we'll see some of the implementations of also and some applications too. Okay, this is a node representation of a linked list node. The node will contain data and next called next pointer. So this data holds some information regarding it, can be either primitive data type or custom data type, and the next pointer is to denote the next node. So this is the one of the linked list representation. This is called singly linked list. There will be a single pointer and one more field called data which holds the information, and the first initial node is called head and the last node is called tail. So one node is linked to the next node using this next pointer. So at a point of time you can link only one node, and this is how it's possible. This will be in random addresses, so the next node will point the next which is coming at the next position. So this holds the address, so this is a pointer. So this is only at a time it can point to one node. This is possible, but this is not possible. You cannot go and link multiple nodes like this. So that time it will be a pointer array, not a linked list. So this is essential information you must know about linked list. So this is only one pointer is there, so it's called a singly linked list. Okay, in this singly linked list itself, if I'm connecting the first node and the last node, then it will become a circular linked list. When I'm connecting this next to this node, and it forms a circle. So from top you can see this is one loop is forming in this, so it is called a circular linked list. So namely how it can be represented as like this. It can be either like this kind of a linear or it's a stepwise, but the actual logic behind this linked list is same. So then there will be a one data holder and one will be a pointer holder. So the next will be pointed to the next node. So where the last node is, it will be pointed to null. So there will be a null pointer. When this null comes, you must stop it because nothing is after this null. So this is called singular linked list and a singly linked list. So this is an example for the circular linked list. This is called a circular linked list. There will be a one node. So in circular linked list, you cannot come to know which is the head or tail because it forms a circle. There will be no starting and no ending. But in real world, you can just point a node as a head for a temporary pointer like head or tail, whatever you want to name it. You can name it as just head, and you can give this address of this node as in the form of pointer, and you can traverse in this and print the nodes. So this is called a circular linked list. You can see this circle is formed because of this pointer structure. So the next is called doubly linked list. Doubly linked list is similar to the singly linked list. Here there will be two pointers, namely called previous and next. So here is the node structure. There will be a node data holder, and there will be a previous and there will be a next. So this is a representation how this doubly linked list look like. So there will be a head node and there will be a tail node. So here this is a head node and this is the tail node. So head node will have previous, next, and the head node previous will be pointed to null because this is the head, so there is nothing before this previous, so this is null, and from the tail pointer the next is null, so there will not be anything after this pointer, so this is null. And this next and previous, how it linked is, it's from the start. This is node 1 and this is node 2 nodes. This one nodes next will be pointed to 2 and the previous node will be pointed to 1, so there will be a loop forming between these two. So I can go here, and with this next I can go here, and with this previous I can come to this one. So if I have this address at the node 1, and I use this next pointer to reach node 3, and again I have to come back to node 1, means you'll not have any reference. So by the time you can use this previous pointer and this previous pointer to come back this node. So these kind of travelings are there with this doubly linked list, so that time it will be very helpful. And this is the one of the, for user convenience, have represented in a steps format. You can see some of the integer data with this linked list. Doubly linked list holds their information. Okay, and next is doubly circular linked list. Doubly circular linked list is like the same as singly circular linked list, and here you can see there is a circle formation. The next, here it points. See here you must understand this. Next is pointer to the node, not to this anything. It points the whole node. So there is 1, 2, and 3, and this is 4, means one's next will be pointed to only 2, and 2's next will be pointed to 3, 3 will be pointed to 4, and 4 will be pointed to the same thing, to first. And here also this previous will be there. Whenever it got next and previous are there, you can see this from next of 1 we'll take this pointer and we'll attach to this 2. From the node 2 we'll attach the pointer of previous to 1. So this is somehow it's linked. Okay, this is how we have to form the doubly linked list, so doubly circular linked list. So we'll see the implementation of these all 4 linked lists one by one. The real-time applications of this linked list are there will be implementation inside of the C++ libraries using this linked list is stack, queues, and adjacency representation of graphs will be there. That time these linked lists will be very helpful. So you could have seen this rocket science and all. There will be large number of integers will be there, and there cannot hold. There will be 30, 40 digits of numbers and all will be there. So these nodes will represent one digit, so that the addition or subtraction, any mathematical operations will become very easier using this linked list. And for dynamic allocations, or you can use, and there are sparse matrices. So there are a lot of applications are associated with this linked list. So we'll see one by one in the upcoming videos. Thank you for watching video. We'll meet in the next video.